So we have this, great possibility of having, cheaper electricity and the ability to sustain our economy and our economic growth with resources that are produced right here in the United States. So the downside to that is that if we don't do that correctly, there can be environmental ramifications.
There's so much emotion tied up in all of this. One person says, oh, there's our energy independence. Some community that's living 20 miles away but is drinking the same water sees nothing but a threat.
When you combine that with some genuine environmental concerns about the kind of drilling activity and the chemicals that are used and water issues and so forth, there are serious issues that have to be dealt with.
Drilling needs water, lots of water. To drill one hydrofracking well, you're going to need about 5 million gallons of water. Now, most of that water comes back up to the surface, where it's now contaminated with salts, heavy metals, and other toxicants. That water is typically stored in ponds, but it has a great potential to drain and impact either groundwater or surface water.
So if we put them into a pond at the surface, we have to line that pond so the pollutants don't trickle back down to the water aquifer. So we have to be very careful that we, while getting our energy resources that are so valuable, don't accidentally contaminate another resource that's even more valuable, which is water.
A lot of times we do these operations in areas where water is scarce, in semi-arid areas. And that creates a serious problem in that it contributes to exacerbating water scarcity, and it represents a missed opportunity for adding value to the wastewater that we have just produced. For example, treated or desalinated to a level that, whereas it may not be fit for human consumption, it might be good enough for irrigating salt-tolerant plants or even to grow food. There are other risks. One of them that is being reported recently is that some of this hydrofracking may induce some seismic activity, more precisely small tremors and earthquakes.
But the earthquakes aren't really induced by the hydraulic fracturing, they're induced by the reinjection wells. So when you do shale gas production, you have a lot of water to deal with at the end of the process. And the question becomes, what do you do with it? In some places, you can reinject the water into an aquifer. In Texas, we've been doing it for decades with no problem, really. If you reinject that water at a fault, you can actually induce an earthquake. So there is seismic activity that happens with hydraulic fracturing, but it's not because of the hydraulic fracturing, it's because of the reinjection wells, which can be many miles away from your actual site of production. We can keep those risks to be very small. And that's really determined by identifying the right geological formation to reinject the water so it's safe.
The industry has come a long ways in terms of minimizing its water footprint in the development of unconventional resources. In the past, we needed freshwater supplies for fracturing fluids. In the last few years, 2 or 3 years, it's now possible to actually use brackish water or saline water, and that's reduced the consumption of fresh water in hydraulic fracturing quite dramatically.
And are thinking or trying to move towards what we call a zero discharge paradigm. In other words, recognize that pollution, in this case water, can be a resource. Hold it and recycle it and reuse it. Treat it so that it is good enough to be reinjected into the formation to make more wells, or perhaps treat it to a better, higher level to remove the salt so that it could be useful for irrigation. In that case, it would be a beneficial disposition of the water.
All of these risks are real, they're non-trivial, but they're also manageable risks. They're all risks that we can deal with if we're willing to take the time and the effort to line our pits, to minimize the number of trucks we need on the roads, to case our wells so that when we go through the water table, the risk of contaminating the water is very small.
We have a lot of experience at this point with what works and what doesn't, and it's important that industry use the best practices that are out there in order to avoid harm to local communities. But we're also going to need to go beyond voluntary measures. We are going to need robust government oversight of what's happening, both because substantively it matters, but also because people need to be reassured. And the company's words are not going to be enough to reassure them by themselves.
The fact that this resource is worth so much money is a great opportunity for all of us. It means there's an incentive economically to get it out of the ground and sell it to us and get it to market. So this is good news. Industry wants to produce this resource. So we can use that economic incentive as a part of the regulatory framework to encourage the right kind of behavior.
And then out of that, you can look at the existing practices. Where are the gaps? Are there any gaps? Who has the best practice out there? And if those rules aren't common in every place, and this is one of the problems, I mean, states that have oil and gas industries, have had oil and gas industries for a long time, have pretty reasonable rules. States that are new to the game don't. So what you have to do is help the places that don't have good rules to get those rules.
A lot of people view it as a black and white. Either there is some environmental risk to drilling, so we shouldn't do it, or we need the energy, so we just have to live with the risk. And, my point of view is, no, I don't accept either of those positions. So I need to require that the technology be developed to the point where it mitigates in the highest possible manner the environmental risk of drilling.
There's a real upside to figuring out a way to go forward with shale gas. Natural gas has the potential to provide a real bridge for where we are today to where we need to be in 50 or 60 years from now, hopefully, using a fuel that is at least cleaner, and apparently now it can be relatively abundant.
These are manageable risks, just like the risks are managed for conventional oil and gas, or just like risks for food, or construction, or anything else we have in life are managed. We can't take the risks to zero, but we can get pretty darn close, and that's a pretty worthwhile step to take.